So recording started. Let me share my screen. Can you see my screen? Presentation? Okay, great. So the agenda is what is master data, and then I will show you what master data we have, and then we have time for a Q&A session. Yeah, what is master data? If you Google around, you can find many definitions of what master data is. I have a link there. You can go and see on your own. But this is my try. So master data help to define parts of objects and usually do not change constantly. All other definitions are a little bit, yeah, I don't understand what the smart people are saying. That's why I always need an understandable translation somehow. Sample master data we are using, for instance, for our address entity is the gender, the country, and the language. And yeah, some wisdoms here. If you go on AS24, you can see a lot of drop-downs, checkbox, radio boxes, and so on. So filter elements. And typically what's in there is kind of master data. And if you do DB normalization, that in the end leads in most cases to master data. For instance, if you have a table and there's like a make name in it, for instance, Volkswagen, and you continue to have Volkswagen over and over again, you end up in adding a make ID to a table where you have an ID and the name Volkswagen. And if you change the name to VW instead of Volkswagen, you only need to change it on one location, like in this normalized table. And yeah, stuff that's always reused and doesn't have that many modification. Also, in most cases, this is kind of like master data. Then we have vehicle type groups table. This is defines the two groups we are working on, or two domains like autoscout24.ch and motoscout24.ch. So every listing that is in our database in the vehicles table has a connection to a marketplace, either Autoscout or Motoscout. Then a little bit more granular, we have vehicle types since 2012. This is also, it has the same structure that the Eurotax has for the first four. Like cars, that is vehicle type 10, then utility or commercial vehicles is 20. Then we have trucks 30, motorcycles 60, campers 70, and trailers 80. So campers and trailers are not available over Eurotax. But all kind of vehicle type listings are in our vehicles table. So we don't have different data table for trailers or campers. They're all in the same table. Of course, there are fields, for instance, beds you won't use for cars. So this that column value in the table vehicles will be always null for cars. And there are, yeah, others, but not that many. A lot of them are shared, like for instance, yeah, horsepowers, except for trailers. Yeah, then we have makes. And makes are always assignable to a specific vehicle type. So a make can belong to multiple vehicle types. So here's a sample. These are the makes for the vehicle type 10 for cars. And we also assign a make to a country. So you're able to search on the extended search for just German cars. If you say, okay, German cars are, I rely only in German cars or whatever. Then models. Models are assigned also to a specific vehicle type, to a make, of course, and they can be grouped. As you can see here, for instance, C-Class has sub models, and they can be grouped in a multi to multi and relationship. So you can assign a C160 to another main model, for instance. Guys, you interrupt me if you have questions, huh? Then we have search value types. Search value types are values we are using for our search criteria, where you can see in the drop downs. And it is kind of a value typed data type, you know, a numeric value like year from this, price from this, kilometers, and so on. So yeah, value types. And for instance, a sample is the price we are having here. Then there's also an HFAD radius. You can find a lot of them here. Doors is also a search type, and seats, and so on. Then search values are defined that way. As I said, it's bound to a search value type. One, for instance, for the price, and there's pipe separated values in it. So whatever is defined here, you can see in the drop downs here. Those are the values, the pipe separated values from the DB. So wherever we want to have smaller steps or increasing the steps or whatever, we can change it here. Refreshing the cache and all good. And we can define them also based on vehicle types. For instance, trucks, they have higher prices than vehicles. So the steps are a little bit bigger than on vehicles. Yeah. Also for doors, could be that a car has seats, a car has less seats than a commercial vehicle, or vice versa, a bus, for instance. That's why we define it differently. Then, as I said, these are value types. We also have a kind of reference types defined in our database. We call them lookups. A sample of a lookup is a fuel type, then a transmission, body types, colors, license categories. We have also a lot of them. So these colors, for instance, are lookups. The condition is a lookup. The drive type is a lookup, transmission, body type, fuel type, and so on. And for each vehicle type, you can define those lookups, and you can also group that way. You can see here for automatic transmissions, we have sub elements or sub lookups. And this is, let's say, yeah, it's a one-to-many relationship. And an example for instance, a fuel type is petrol, diesel, electrogas. Or as you can see here for transmission, it's these ones. All good so far? Then we have bitwise value types. And I'll come later to how they're calculated, because that's mainly the most question I get from developers, PMs, or API users, customers. We have 4 types. One is the equipment bitwise value, mainly used for searchable equipments like ISOFIX, 360-degree cam, distance control, and so on. Then we have properties like, let's say, vehicle conditions, like if the car had an accident already, or if it's an export car, direct import, if the car is tuned. Then we have extras. This is kind of like out of what the manufacturer has given to configure in the equipments, like 8 tires, a dog grid, freezer, a crane, whatever. So really additional, special, extras. Then internals, this is bitwise value we can set for internal purpose, like if a vehicle is marked to order, highlight, hide origin price, and yeah. So these are 4 types we can define at the moment. Then what is what can we store within a bitwise value? We use the data type big int for the bitwise value, and this is from 2 power up to 33 minus 1. So this is the maximum value we can store in the bitwise column. So we can store this value for internals, for equipments, for extras, and properties, because all 4 has an own column in our database. So that's a huge number, but it's not that many values we can store in that number. We can store maximum 62 equipments or bitwise values in such a number. We can hide the configuration of 62 bitwise values in that number. Currently, we're using 49 bitwise values for the equipment. So if you count those, you end up in having 49. So we still have potential to add new equipments, but not more than 62.
Only one question. Negative number will be also give you again 62, right?
No.
No.
No, it's not possible because of the calculation. You will see later. Or you can teach me otherwise. Yeah, so let me come to the calculation very soon. Is that okay? Then you can maybe re-ask. The basic for binary codes, so an excursion was somehow invented by Gottfried Leibniz. I mean, all other people also did research on that, but the basis for that was by this guy. How the bitwise calculation works. Like for a binary system, we have, as I said, till 2 power up to 62 values for a big int, size for a big int. And let's say if an equipment has the value 1 and another one has a value 2 and another one 4, 8. So we can assign those numbers to 62 equipments. And we configure a car that has equipment A and D, so 9. We sum up this, so 9 will be in the vehicles table. And now, let's say, what has the car? Has he equipment 1? Has he equipment 2B? Has he equipment C? Has he equipment D? Let's check. So we can check if the sum is included, if we logically AND the sum and the value, and it equals the value. So let's do the first try. The sum is always 9, you see, huh? 9 for binary values. The sum is always 9 because we said this one has A and D. So the first one is a 1. And 1 is 1. 1 and 0, 0 and 0 is 0. So 0 and 1 is 0. Logically and. So it's a 1. Yeah, it is. And the value equals the value. So it's okay. So it's an A. Is it a B? No, 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 no. It's 0. No, it's not a B. Is it a C? No, 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 no. No, it's not the C. Is it a D? No, no, no. Yes, it's an 8. Ah, I have an 8. Value equals value. So it's an 8 too. And now you can do that for all kind of values. Second. So these are the bitwise values. You can see it's always a 2 powers 6 is this number. 20 power 2 powers 20 equals this power. 90 powers 2 powers 19 equals this power. So these are the bitwise values that are stored in our database. And as you can see, for instance, Isofix has this power, so it equals this value. And if you have the sum of these values, those won't match, you know, it's just these would match. Yeah. This is just for cars, huh? So 49 bitwise values we have. But you can also do it with sum or the value equals the sum. It also works for checking if my equipment is within this sum. So the advantage here is you could use int, a big int, which is a logical operations where the calculation is very fast. So it's really fast to calculate those values. I can tell you, that's why our searches are also that fast. You could store equipments differently. You could store them as flags. For instance, like we have a bit for a true or false for, or a Boolean for is accidented, true or false, is to order, true or false, has isofix, true or false, or whatever, but you end up in having a huge amount of columns and a really big query. And it's also not that easy to index all that stuff. And yeah, you could also store it comma separated and do a query with like on SQL Server, but that's much less powerful or fast than this logical calculations. All good so far? And now, before we had in the search criteria, for instance, for the front end, I mean, you guys are all smart people, I know, but before we had, oh no, it's still the case. We do the sum here, and we go with that sum onto the database, and we can execute the query based on that sum. But for instance, for API providers, if we need to tell them how we calculate those these stuff and how they should handle it with our master data, it's very hard for them to understand. That's why we also have parameter search possibilities, but I don't know the parameter at the moment where you can put it that way, you know. And we translate that parameter, the selected values into a number, and then we execute with this number on the database. That's just for supporting the guys or the partners or whatever who do not understand how this calculation here works.
Can I just ask something? If you have the sum, can you explain again how you get all of them?
How I get all of them? Yeah,
Yeah.
let me show you a sample. We have, for instance, vehicle ID 11. Huh? I'm pretty sure after that meeting session, a lot of front-end developers will want to move to backend because it's cool to do stuff like that.
No, we are okay.
Here, you're okay, okay. So, for instance, for this vehicle, we have this equipment set. Huh? This is a huge number. And now what we can do is we join over our bitwise values, also our translation, that we have nicer descriptions. And I say, give me this vehicle ID I have here, huh? The 11. Then the type is, with that join here, the type is equipment, huh? Just equipment. And I do logically and the bitwise value here, I'll have here with the sum here in that field equals the sum. And what I get is all the equipments this sum here includes. So one, if you do you can do the binary stuff also with, for instance, this one. And it matches.
Exactly the same thing is happening on the front end because we need to find out which checkboxes to check. So we also do the bitwise AND. But the thing is that the browsers doesn't support big int. This is the problem. So we have a specific specially installed the big int module for which works with the big integer values as a strings. because browsers don't support big int. Int is maximum in the browsers. We need
Okay.
to programmatically extend it. But it's one-to-one as on the client side.
Let me try this and oh, what was the first thing I added? This one, huh? Wait. Oh, sorry. The decimal. This value in binary and this value in binary equals this value again, huh? You see. So this
It's
logically and with this ends up in being this one.
This is called the bitwise mask. So
yeah.
it's bitwise masking. So if you do the logical AND, it checks if the value is included in the value, something like that. It will either return 0 or the value which you are checking.
Okay. So far, so good about bitwise values or masking.
Yes, thank you.
Then we also have table attribute types. We use this one for generic stuff like business hours, warranty, phone types, car documentation. There's a lot of attributes we defined. No, sorry. These ones. And each of them has attributes. For instance, for business hours, it's the type of a business hour. Is it the sales number? Is it the central number? Sorry. No, is it for sales? Yeah, central, the garage, customer service. And then for the phone types, is it private phone address, phone number, business one, Fox, showroom, 24, hour availability or whatever. So you can see it here. So those are attributes, really generic one. And I will show you the problem we have on the DB or the trade-off we have on the DB that we designed a generic possibility to have attributes on our platform. And some of these attributes also have special cases. That's why we have an attribute settings table. For instance, for the user types, so there's the possibility to have JSON data in here you're using in the code. But that's just for special cases. And then we have others like attribute address types, billing categories, paper online, countries, Switzerland, Fürstentum, Liechtenstein, duration, seconds, minutes, hours, industries, garage, tuning, carrossery, motto, roles. We're using for our authorization, the AS24 admin role. Everybody has here. Sales, the private user, and status types. If it's a status for a user, a vehicle, or a contract, and then we have the status itself. Is it active, deleted, inactive, expired, whatever. User types, private dealer and agent. So why is that not an attribute? It can be an attribute because it's just these declarations. These could also be an attribute. This could also be an attribute. This was designed before we had the attributes. That's why they're separate, in a separate table. But in some cases, it also makes sense to have it have that stuff separate. And I will show you the trade-off now. Huh? So the good and the trade-off here is, if you, for instance, have a table just for the vehicle types or the address types or whatever, you can do a foreign key on the vehicles table just for this column. So you cannot store something different there. But if you, for instance, have the lookups, and you have different kind of lookups, like the fuel types, electro, benzene, and then you have the body types in the same table, like coupe, combi, whatever. They all have a foreign key to a special column, like condition type is a foreign key to the lookups table. A body type is a foreign key to the lookups table. And what can happen here is that you could store a condition under a body type if you do it wrong on the application side. And we had one thing in our migration once happened that we stored wrong values in the wrong column. So if you would have a conditions data table, a body types data table, a segmentation types data table, you could do a foreign key just on this table and you're safe. You cannot store anything else than the numbers that are in there, you know, but you end up in having much more tables on the database. So now you can blame me about how the design is. If you want to do it strictly, you would end up in having different tables. But yeah, so in the end, you don't have the overview anymore. The same for the attributes. You would have a lot of, I mean, look at the amount of tables we would end up in adding, like 25. And there's also already code written. You know, if you want to have an attribute from a specific type, you can just add an enum for the phone types, and then you can give me all attributes for phone types or for job types. Just adding one property and you'll get the other information. So per design, it's much easier to have it that way on application side, I'd say. Yeah, I'm almost already through the presentation. Yeah, as I said, we can save a huge amount of tables. We can reuse code algorithms. That's the advantage here. The trade-off, we can have data inconsistency. Yeah. That's mainly it in terms of master data. We also have it here somewhere. Where's the master data in the initial endpoint? Oh shit. here I need to authorize. Takes too long. Yeah, as you can see, this is also kind of master data. So on a lot of endpoints, this is master data. So on the web, for the web app, for the web applications based on React, we are using this API, and we return the master data in a JSON structured way. Yeah, and you can see all the values I was talking about before. Yeah, that's mainly it in terms of master data. Questions, feedbacks, tech debt we need to discuss, or other like good ideas for doing things differently. I mean, you can come back to me later, but if you think we have something for the round that is interesting, or we need to go through a little bit more in detail. Was it all new to you, or like just old socks?
For me, it was good to hear it again, but I probably have to go through the Bitwise stuff once more till I really get it in detail. But I think if you have the query, this already helps a lot.
Yeah, I'll share the presentation, I'll share the video later, and I'll have also like queries here you could execute if you have access to, of course. There's, for instance, also one that shows you all the possibilities. Like it just does a loop over all powers, and it returns like those. No, it's actually 63 possibilities we can store in the database, because 0 is also possible. Yeah.
Yeah, I'm gonna
So
have a
long
look at
numbers.
this bitwise stuff as well, but maybe we can have a bit a deeper dive session.
Yeah. Yeah.
For this
Or
another time.
yeah. Yeah, whatever you want, or just post me questions, and I'll come to that back later.
Regarding the attributes and either creating attributes or a table, but do you think it's much? Is there a performance issue? Why creating a table is a problem? What do you think?
No.
If
No,
we have
no.
like more
No, there's
tables?
no performance issue. No.
Okay, it's just that
Also,
we
the
create more
amount of
tables.
data is I'd say the amount of data is also not that much a difference. So you would prefer to have multiple tables. So a table for phone numbers, business hours, and so on.
What I would prefer. Well, at least the data is in the database.
Yeah.
But not really Monster. It's not. But I would prefer one over. Over is just that. Yeah, at least you can see directly where is the
Yeah.
data.
Yeah, it's
But
depends on your taste, you know. It's
exactly, it's just it's not one all over. It's just
yeah. But I agree. If you ask a DB expert, he says, "Oh, what are you doing here?" You can end up in having yeah, inconsistent data. But I can tell you, you always have things like that in in a generic database.
yes, yes, you always need
You
this
know,
kind of
a generic database is not that readable, and you need to do a lot on application side to present then the stuff in a readable way. If you just look at the database, ooh, it's all is in
huge.
one table. I mean, Anibis DXbase was kind of like a generic database, very flexible and so on, but like if you, in terms of consistency, I'd say trade-offs, yeah, or risks.
Yeah, I mean, if it's something that won't change a lot, you can also go with the attributes directly. Because when you don't need to change, because you don't want to like update the or yeah, have to change the application every time because of kind of data, right? I think that's what you have to consider. But, yeah.
Hello. Hello.
Hello.
So in case of a vehicle table, if we want to make it more generic, can we move the column? Can you go back to the slide of vehicle?
Where? Sorry.
Yeah. Slide 19. Yeah. Thank you. So so in so all columns in the blue round, can we move it into another table? I want to make it more generic, like we want to add convert it from column to row. Like we have a time here, so in case we add another time, we have to add a column here. But if we move to another table, is it good, Oliver?
What do you want to move? Sorry, I didn't
All
got
the columns on all the columns here, yes, in the blue round here,
yeah.
blue circle here. So we move it to another table, make all the columns in becomes rows. The rule to make the generic table is convert the column into rows. Is it right?
Also, you gain nothing if you put those into another column into another table.
Yeah.
You also have a
because in the
binding
lookup,
to the
yeah.
lookups table. In the end, you would end up in killing this lookups table, adding a conditions table, a body types table, a segmentations table, and then you can map those to the vehicle. I mean, what you could do, you could also use bitwise values with IDs, like adding IDs together in one field. But in my opinion, a bad idea. In the end, you need to add a lookup here that is existing here. It can be a body type in the conditions table, I agree. That's the trade-off. But yeah. Look, redesigning that stuff is a little bit harder to do because it's very deep in the core. You need to update a lot of code, I'd say. And the ugly thing here, what I don't like more here is that we have other informations into the vehicles table than the vehicle, like the vehicle definition itself. We have listing informations too here. So I would split vehicles and listings information, but that's another topic.
So with this schema, if I add a new lookup, do we add a new column? Yes.
Exactly.
A new lookup.
If you add a new lookup, you add here a new column. You add a new lookup type.
Yeah.
And then the values of the type in this table.
Yeah. So that's what I mean. I want to add a new lookup without adding a new column to the vehicle table by separate into the another table. That's the idea.
Okay, but the other table would contain also those values. It's just moving those out of the vehicles table.
All the columns here will become the rows. Like
rows.
Yes, records.
Yeah, or otherwise we take a look at it later. But what I thought you meant this, like creating a new table. But that's the live server, not that a good idea to experiment on. Then you add those. And then things like that.
No. Column. The column name will be vehicle ID. Looks up ID.
Aha.
But how do you enforce?
Yeah. Because we have lookup. Because based on lookup ID, we have lookup type, and we here we have that lookup type in the format of column name, like this. Yeah.
But you can also add. Aha. Yeah.
But I ask your opinion. Is it good?
Mm-hmm. Yeah, in terms of searching, you need to join another table. That's why it's, look, we once said we don't want to join when we search for stuff, because we did the search on the database, and we still do. So that's why if you would have this many-to-many table, you would need to, if you search for the condition type, you would need to join this table and eventually also multiple times, you know, for different vehicle types.
Yeah, sure.
So you have a lot of joins.
Yeah.
And I'm pretty sure that the query will get much slower. But I agree that it's nicer designed for like adding lookups to vehicle. I agree. But that's the same for the bitwise values. It's all made for having good performance on the database. It's not only like, okay, let's just do perfect DB design. If we do so, we would end up in having much more tables, and if we search for stuff, we would end up in having much more joins. So it's not that we are like not knowing how to do DB design and so on. It's we always thought about how we can also do it much more or much faster. You know what I mean?
Yeah, I understand.
Yeah, you can say, okay, that's just an excuse, but it is so. We had SQL Server for searching our data. That's why we needed to be very fast. But if we have a Solr instance and we don't do the search on the DB anymore, I'd say we can discuss things like that to redesign these things. I agree.
And second question about what are differences between a lookup and a search value table? The purpose of the two tables.
The lookups is kind of like, as I said, you can look at that as an object, a reference type to different values, and search values are search values are numeric values, so value types.
Mm-hmm.
You don't need to have a join to a definition of what the value here is. These are just integers, decimals, maybe strings or whatever.
Okay.
Value types.
Yeah. Thank you.
All good? So I'd close the session for today, and I will post the links to the presentation and the video. And yeah, I wish you a nice day, and let's see hopefully tomorrow for the scheduled jobs.
Thank you very much.
Thank you.
Thanks.
You're welcome, guys.
Thank you. Thanks.
Bye.
Bye bye, guys. Bye.